everyone. This video is again another Mod Podge of a bunch of stuff from Chapter 2. This is going to go over accuracy, precision, sig figs, units, and density. Or at least that's what I have written down. So I guess I'll just get started. So first I'll start with accuracy versus precision. Accuracy indicates how close a measurement is to the accepted value. In other words, how close is it to what we know is correct? So just think about it. Accurate equals correct. The more accurate something is, the more correct, the closer it is to the known value. While precision is not spelled like that. Precision is, come back. Okay. Precision indicates how close together or how repeatable the measurement is. Or in other words, the more precise something is, the more consistent. I think we've all seen the picture of the archery target, and accuracy is if you have the target, it's they're all in the middle, where precise is more like they're all over in this one general area. So that's accuracy and precision. And the next thing for this is sig figs. So significant figures they indicate accuracy, again, not how you spell that word, of a measurement. There are many rules that go with sig figs. But when you do the measurements, remember, the measurement includes all known digits plus a final estimated digit. If you remember that kind of lab we did while we were online, where you have a ruler stuff, and say your ruler is, say this is a ruler and your line is like here, so your known digits are 10. I'm going to move this over a little. So our known digits are 10.3. We can see that. And then you have to estimate kind of this final one. So it's 3.5 because the ruler goes by tens. So you have to estimate that final one. So when you're doing significant figures, you count all numbers as significant except, I cannot spell today. Except leading zeros. So say you had like 0.0025. These are leading zeros, so you would not count those as significant, so this would just have 2 sig figs. You also do not include trailing zeros. So trailing zeros without decimal places. So say you had 25,000. Since there's no decimal place, these are trailing zeros, and that again only has 2 sig figs. So those are the ones you're gonna exclude. You're not gonna count those. You are going to include non-zero digits. Anything that is not 0 is significant. Sandwich zeros, so those are zeros that are in between non-zero digits. So like this one. So this one, these are trailing zeros. You're not going to count these, but you are going to count these because they're sandwiched in between these two, so that's 4 sig figs. You're also going to include final zeros after the decimal. So again, if we did this example again, 0.00400400, these again are trailing, they don't count. All of these after this significant digit do count, because, you know, this one we have to know to include it, and then that one's the estimated one. So this is 6 sig figs. And then all digits before the mantissa, or the multiplication sign in scientific notation. 4 and because we wouldn't have those there, because how scientific notation works, you only have the digits that you know you need. So like 5.0 times 10 to the third. These all are included. That's 4. Not the 10. That's 4. So, and then there are some exceptions, just like language. So exceptions are going to be counting numbers. So that's going to be numbers which are counted or are exact. And they're going to have infinite sig figs. So that would be like, you know, 23 cars. You know, we're not estimating how many cars there are. We know there are exactly 24. It's not any guesswork, and you know, you're not going to have half a car. So, you know, that has infinite sig figs. And then defined quantities. Oops. So quantities that are related by definition, again, have infinite sig figs. So this would be like 1 kilometer equals 1,000 meters. Both of these have infinite sig figs because that's a known thing. That's defined. You know, we know this for So now, that's the rule when you just have, you need to know the sig figs of just random numbers, fill in the chart. Now, if you're doing multiplication or division, there is not a D in division. Oh my goodness. Division. Okay. There are some other rules. So your answer is limited by the least accurate measurement, which would also mean the least number of sig figs. So say you have, 5 times 5. 5 centimeters times 5 centimeters. So that equals 25 centimeters squared, right? Well, 5 only has one sig fig, and this 5 only has one sig fig. So our answer can only have one sig fig. So we're going to have to round up, since that 5 will round that 2 up, and this would be 30 centimeters squared. Same thing for division. 3 grams divided by 4. Oh, the ruler came again. 4.42 centimeters cubed. So you get 7.85746 grams over centimeters. But so this, the top number has 4 sig figs. The bottom number has 3. So we're going to limit our answer to 3. So 1, 2, 3. That's 7. We'll round that 5 up. So we have 7.86. So that is multiplication and division rules for sig figs. There are also rules for addition and subtraction. Addition, subtraction. So, answer for these. So, answers are determined by least accurate measurement, or in this case, the least number of decimal places. This one is decimal places. This one is sig figs. So say, 138 plus 82.1 grams. So even though this one has, plus 1.39. So they all have 3 sig figs. But our answer isn't going, so when you add these up, you get 221.4 grams. Now, these all have 3 sig figs. But when you do addition and subtraction, you're going to the least decimal place. And so since 138, because that would be the least accurate, because, you estimate that final one. So, this is very inaccurate since we don't have decimal. So since the 138 is the least accurate, this is just going to have no decimal points. So this is going to be 221 grams. And then say you have division and subtraction together in an equation, just go with sig figs. That's going to be the easiest way to do that. Okay, and then one more thing. Wow, this video is a bit long. Just density and density, I can spell anything, is, density equals M over V. Density equals mass over volume. And so, just to remember for this, your density is going to be, the units for that are going to be like grams over centimeters cubed, mass is going to be grams, and then volume could be centimeters cubed or a milliliter. They are equal to each other. And then, you just plug these in and divide. So, say your volume is 2.0, your mass is 16.0, and so then your density would equal 16 over 2, which would give you 8.00 sig figs, since they both have 3 grams over centimeters cubed. I think, we all know this by now. So that is it. That was a lot of random stuff kind of together, but good review for the midterm. And speaking of review, I'm having a Zoom review December 12th, 2 p.m. Just get in touch with me for the link. And that's about it. Thank you so much.